right, in this next example, it is a cubic, and on the surface, I was like, oh wow, how do we solve this thing? Then we got to think back to our factoring techniques. Is one of our factoring techniques something that we can apply to this particular problem? And if you look very carefully, how many terms do we have? Do you see how we have 4 of them? And the only factoring technique that we are aware of is factor by grouping. So let's try that, because if that doesn't work, we're going to have to learn something else. So what can I factor by grouping? You split it up into 2 sets of 2, and you look for the greatest common factor for each set of terms. So what can I factor out of x cubed and 7x squared? And I can take out an x squared. Leaves me with an x plus 7. And what can I factor out of negative x minus 7? And I can take out a negative 1. That leaves me with x plus 7. And if you do factor by grouping correctly, you should have those 2 parentheses, the 2 binomials in there should match. Okay, so in factored form then, I get x squared minus 1 parentheses times x plus 7. Okay, now, do you notice that one of those is again one of our factored forms? It's difference of 2 squares. So x minus 1, x plus 1, and x plus 7. Okay, so, and all of that I want to figure out, or that's going to be less than or equal to 0. All right, so again, first task, after we've factored it, is to find where it crosses. And if I go in and solve each of those binomials, I get that x is going to equal positive 1, negative 1, and negative 7. So that's what I'm going to set up on my number line. Negative 7, negative 1, positive 1. And now I just need to pick some test values. So something smaller than negative 7, like negative 8. Something between negative 7 and negative 1, negative 3, sure, that makes sense. Negative 1 and 1, 0 would be a good candidate for that. And anything bigger than 1, like 2. And then I'm just going to evaluate each of those test numbers into my factored form and identify if I get a positive or negative result. So let's start with the negative 8. So imagine if I evaluate negative 8 there. Well, what would I get each time? Well, negative 8 minus 1, that's a negative number. Negative 8 plus 1, that's a negative number. And negative 8 plus 7, that's negative. So I have 3 negative things that I am multiplying together. So that means my result is going to be negative. And then we'll go on to the next number. Next number is negative 3. So if I evaluate that at negative 3, I get negative 3 minus 1 is negative. Negative 3 plus 1 is negative. And negative 3 plus 7 is a positive number. All right, so what happens if you multiply 2 negatives and a positive? You should get a positive result. Let's try 0. So put a 0 in there for each of those terms. 0 minus 1 is negative. 0 plus 1 is positive, and 0 plus 7 is positive. And so if I multiply 3 things together, 1 will be negative, 2 positive. I get a negative result. And then the very last case, you can kind of guess if you kind of see the pattern here. 2 minus 1 is positive, 2 plus 1 is positive, and 2 plus 7 is positive. And when I multiply 3 positive things together, I definitely get a positive answer. Okay. According to our symbol, what am I interested in? I want to know, where does this thing negative or 0? All right, so I can see that it is negative when it's less than negative 7, and that it's also negative when it's in between negative 1 and positive 1. So my inequality is negative infinity up till negative 7, and then negative 1 up till 1. Okay, and I put brackets on there because it said less than or equal to. So the or equal to piece means I want to include my endpoints, which is why there's brackets on those values. All right, next type of inequality we're going to solve are rational. These are very similar to the rational functions we've looked at recently. Let me kind of scroll down. So we're talking about these sorts of problems that have fractions in them. That's what we'll look at manipulating. Okay, so what are the steps that we do? We want to, number one, move all terms to one side. Move all, wow, I'm going to try that again. Move all terms versus what I just wrote to one side. Then, if we don't have a single fraction at that point, we want to rewrite the one side, so the left side, using fraction rules. So we have a single fraction, so we might have to do a common denominator if we already don't have one. All right, now step 3, we're going to find the intervals where the polynomial function changes signs. That's very similar to the previous problems we've looked at, except now we have a fraction case. And in essence, we're going to set the numerator and denominator equal to 0 and solve. Then, in step 4, we're going to use test values. So this is just like the other polynomial inequalities we've seen. To test within each interval to determine the sign of the rational function within each interval. And we're going to label a sign chart based on these test values. And then lastly, number 5, we're going to express our answer in interval notation based on the sign chart. Now there is sort of one caution, so I'm going to put a little asterisk by that. Just be aware that even though the symbol will switch from less thans and greater thans and less than or equal to's or greater than or equal to, so you'll have a symbol there, because it's a rational inequality, we can't always put brackets on it, even if the symbol says put brackets on it. And you're probably thinking, well, wait a second, why is this different? Well, since the values defined by the denominator are also values that are excluded by domain restrictions, then all the intervals defined by the denominator are excluded. In other words, any number I get out of the denominator, even if the symbol says or equal to, I can never put a bracket on it because that number makes my fraction undefined. Okay, so it's a little bit of a catch, and again, we'll practice this and see some examples on this. Okay, so these first two are kind of, if you notice, they're the same fraction. The only difference is the symbol in between them, and that's mainly to emphasize, what happens when we have a or equal to piece. So if you recall, our steps are put the fraction on the left, rewrite if needed, so it's a single fraction. Luckily, we already have that in there, so that's nice. Then we're going to set the denominator and the numerator equal to 0 and solve. Okay, so we get x is -5 and x is +2. So those are the numbers that I'm going to label on my number line. Those are the things included in the answer. So now we just need to pick some test values. So something smaller than -5 like -6. Something in between -5 and 2 like 0, it's always a good candidate. And something bigger than 2 like 3. And those are the numbers that we're going to use to evaluate these fractions. Now I'm going to go ahead and set up a fraction bar, and you'll kind of see why here in a second. To kind of help me remember that I'm dividing this whole time. Okay, so let's come up here and let's put a -6 in. So put a -6 in for both those x's. Well, -6 plus 5 is a negative number, and -6 minus 2 is a negative. So what is a negative divided by a negative? That's a positive. Okay, kind of see how that worked? That's why I have that fraction bar there, so I can, oops, move this thing around. Okay, let's try 0. So put a 0 in there. 0 plus 5, I get a positive result, and 0 minus 2, I get a negative. So what happens when I divide a positive by a negative? I get a negative result. And then the last thing we'll do is the 3. So 3 plus 5, I get a positive answer. 3 minus 2, I get a positive. And what do you get when you take a positive over a positive? You get a positive result. Okay, so what are we interested in? Well, the symbol says I want anything that's bigger than or equal to 0. So I want positive values. Okay, so that means anything before -5 and after 2. Now, the question is, what's happening at -5 and 2? Can I include those? Well, the 5 came from the numerator, so that's fine. The 2, however, was a value that I solved by looking at the denominator. So can I ever actually include 2 in this as a solution? And the answer being no, because 2 is excluded in the domain. It's not actually a part of our solution set, so I can't really include 2. So that's what I want to write out on my inequality here in interval notation. So I want to go from -infinity up till -5 with a bracket, then union, and then I want to start off at 2 and go out to infinity. And again, the only reason why 2 does not have a bracket on it is because it's a number from the denominator, and we cannot include those in the solution set. Now if we go next door to this other example, it's the exact same problem, so exact same number line, exact same sign chart. So we did all that work, we'll just take advantage of it. This time I want negatives. And it's less than, so I don't have to worry about the brackets at all anyways. So I want anything less than 0, and so that would be from -5 out till 2. Okay, so hopefully you get the impression that not only do you have to remember which characteristic you're solving for, but you got to watch that symbol, because that symbol will really change the type of answer you have, and you just don't want to overlook something and miss silly points for something that you could have gotten fully correct. All right, so we're going to look at the little more complicated case. So what happens if it's not just a basic fraction on one side and I have to move a number over? So let's do that. So let's take x plus 3, x minus 3, and if I bring the 1 over, it becomes a -1 greater than or equal to 0. So our next task is to find a common denominator, and so I'm going to rewrite that 1. Now I'm going to rewrite it as x minus 3 over x minus 3. So notice I just used the exact same denominator that was already there from the first fraction. And now that they have common denominators, I can bring them under one fraction. So x plus 3 minus x minus 3. Okay. And I can see that I can do a little bit of simplifying. So I can distribute that negative in. So I get x plus 3 minus x plus 3 over x minus 3. And what happens up top? What happens to those x's, right? So the x's cancel out, and I'm left with 6 over x minus 3 is greater than or equal to 0. Okay, so actually our number line got a little bit smaller because that's our simplified fraction, and I don't have a numerator that will let me solve for anything. It's just the number 6. So I'm worried just about that denominator, and what number would make that denominator say 0, and that would be the number 3. So I only have to test point just the number 3. So I need something smaller than 3, and 0 happens to be smaller than 3. Remember, 0 does some great things when we can use it. And I need something bigger than 3, like 4. And then I'm just going to evaluate each of those test numbers into my simplified fraction and see whether I get a positive or negative answer. So let's put 0 in there, for example. 6 is positive up top, so I already know that. 0 minus 3 is a negative number. So what's a positive divided by a negative? That's a negative. Let's do that same thing with 4. So we have 6 up top, so that's positive. And then 4 minus 3 is a positive. So a positive over a positive is positive, right? Okay. So looking at our sign chart, what do we care about? We want anything bigger than or equal to 0. So we want positives, right? And that stuff bigger than 3. So I'm going to write 3 out to infinity. And so the question that I want you to think about just for a second that I'm about to answer is, should I put a bracket or parentheses, and why? Okay, remember, with rational inequalities, I cannot bracket anything that's found from the denominator. So where did I get the 3 from? I got it from the denominator. So even though the symbol says to put a bracket, I can't. I have to put it in a parentheses on that because I cannot include the number 3. It's outside the domain of this particular function. Okay. All right, let's go to the last example. Again, a little more complicated, so a little more work involved, but that's okay. I'm going to bring over the x plus 3 and the x minus 5 over to the left. So 2x minus 1 over x plus 4 minus x plus 3 over x minus 5 is less than or equal to 0. And now I need to find a common denominator. Well, unlike fractions are nice, that it's always easy to find a common. I'm just going to multiply the two denominators together, and then I'm going to multiply each of the numerators by the thing that was missing. So in this 2x minus 1 over x plus 4, what did it not have of that common? It didn't have x minus 5. And the x plus 3 over x minus 5, what was it missing? It was missing x plus 4. Okay, so now I can do some simplifying, some multiplying. So we get, let's see, 2x squared minus 10x minus 1x, so minus 11x plus 5. Then we have that minus. And then if I multiply out the x plus 3 and the x plus 4, so I get x squared plus 4x plus 3x, so plus 7x plus 12. Okay. And then I want to make sure to distribute the negative in here. So that I'll just rewrite. So we have 2x squared minus 11x plus 5 minus x squared minus 7x minus 12 all over that lovely denominator, right? Okay. Well, do you notice anything that cancels out or disappears on us? Let's see. So 2x squared minus x squared gives me an x squared. Minus 11 minus 7 is minus 18x. And plus 5 minus 12 gives me minus 7. And that's all over x plus 4 and x minus 5 is less than or equal to 0.